12.4 Aldehydes and ketones. Now we've talked before about a carbonyl group, but just to remind you that the carbonyl group consists of a carbon to oxygen double bond that is very polar. Let's see why, some of the reasons why it's very polar. Well, oxygen is very electronegative, and it has these two lone pairs of electrons that are unshared here, and so because of this is creating a very partially negative area here, which inherently means that it is causing withdrawal of the electrons towards this area, which means that leaves carbon partially positive. And that's a big reason why you have the different reactions that do go on in aldehydes and ketones. Now, to remind you what an aldehyde looks like as opposed to a ketone, our aldehyde, next to the carbon of the carbonyl group, there's a hydrogen. I mean, there might be two hydrogens, but there has to be at least one. Okay, now look at this carbonyl group. On both sides of it, it has carbon chains. So a ketone has the carbon chains on both sides of it. The aldehyde is attached to at least one hydrogen atom onto the carbon of the carbonyl group. An aldehyde, in naming aldehydes, an aldehyde has an IUPAC name in which the E of the alkane name is changed to al. Now, some of the old common names for the first four aldehydes use the following prefixes, and then they call them aldehyde. Okay, so like you've heard of formaldehyde. Well, the reason why you've heard of formaldehyde, besides the reason why you've heard of it, but the form is from the Latin. It's from one carbon, and it's an aldehyde, and so formaldehyde. Let's look at some examples here. So here we have one carbon and here's our carbonyl group. You'll notice that it's an aldehyde because it has at least one hydrogen attached to the carbon. Well, so we're going to take the one carbon prefix, meth, fen, and then we're going to drop the E and add L. So methanal. The old common name is formaldehyde. You don't really need to know that, but you do need to know that how to name the aldehydes. So here is a 2-carbon aldehyde. We know it's an aldehyde because we have a hydrogen attached to the carbonyl group. So it's 2 carbons, so it is ethanal. We have 3 carbons of this aldehyde, so propanal. We have 4 carbons of this aldehyde because the carbonyl group has a hydrogen attached to it, butanal. So in naming aldehydes, you name the longest carbon chain containing the carbonyl group by replacing the E in the alkane name with al. Then you name and number the constituents by counting the carbonyl group as carbon 1. Now let's look at an old common name that is also the IUPAC name. Usually the IUPAC name is not an old common name, but here's one that is. Let's look at benzaldehyde. It's an old common name that retains its name with the IUPAC naming. Notice how they combined benzene and the fact that it's an aldehyde to come up with the word benzaldehyde. So I just wanted to point out that this is an example of the old common name that is also the IUPAC name for an aldehyde. All right, so let's do a little bit of practicing for the IUPAC name for aldehydes. Don't need to worry about the benzaldehyde derivatives. Let's not go into that. You don't need to know that much expertise. Let's just do some simple aldehydes. And the biggest thing is to be able to identify, is it an aldehyde or is it a ketone? We know it's an aldehyde here because we have our carbonyl group with a hydrogen attached to it. But press pause, see if you can name it. All right, here we go. We're going to name the longest carbon chain, 1, 2, 3, 4, 5. So it's pentane. We drop the E and add Al. Pentanal. We know that the aldehyde carbonyl group has to be on the end because that's why it has one hydrogen. So it's inherently always carbon 1. So because it's always carbon 1, we don't have to say it's on carbon 1 because we know it's on carbon 1 because it's an aldehyde and it starts out there. So then 1, 2. So here we have our methyl group on carbon 2, so 2-methylpentanal. Now we have several naturally occurring aldehydes that are used as flavorings for foods and fragrances. So we have our almonds and our vanillin and cinnamon, and makes me hungry just thinking about chemistry. All right, naming ketones. When naming the following ketones in the IUPAC system, the E in the alkane name is replaced with -one. In the old common name, the alkyl groups attached to the carbonyl group were named alphabetically, followed by ketone. So let's look at this, and let's look and see why the IUPAC name is the way it is. So 1, 2, 3. 3 carbons, so it's propane. It is a ketone. So why is it a ketone? Because we have the carbonyl group with carbon groups on both sides, not a hydrogen. So it is a ketone. So by ruling, we're going to drop the E, so we're going to drop propane with the E and add -one. So propanone. So guide to naming ketones. Name the longest carbon chain that contains the carbonyl group by replacing the E in the alkane name with -one. Number the carbon chain starting with the N near the carbonyl group and indicate its location. Name and number any substituents on the carbon chain. So let's see if we can name this. Press pause and come back. All right. Well, we know it's a ketone because our carbonyl group has a carbon group on each side. So now then, we got to figure out where it's located. Well, the carbonyl group is closest to this end, so we're going to have to number it because it could be in different spots here. 1, 2. So it's 2-hexanone. Okay, so if we're starting, since we have to start from this end, 1, 2, 3, 4, then it's 4-methyl-2-hexanone. Now, if you can do that, you know even more than you need to probably know, because that's probably really more complicated than you would see for a question of naming on your exam. Now, we have some ketones that are in common use. Our propanone, the common name, is quite often used as acetone. That's the solvent in fingernail polish remover. You probably have that. Not that I eat margarine, but I like butter. But if you wanted to know why margarine tastes like butter, it's because they had butter flavoring. And the butter flavoring is actually a ketone, but it's a 2-ketone group in there. So butane dione, di meaning 2. So, all right. So here's a big key here. Can you classify each, is it an aldehyde or ketone? You need to be able to do that. Okay, so press pause, see that you can do this. Okay, so hopefully you figured out that this was a ketone. Why? Because this carbonyl group has a carbon chain on both sides. B, aldehyde. Why? Because this carbonyl group has a hydrogen on one side. C, this is an aldehyde. Why? Because this carbonyl group has a hydrogen on one side. D, here's our carbon of the carbonyl group, and on one side we have a carbon chain, and on the other side we have a carbon group. So it's a ketone. All right, one last learning check. Now we're going to identify aldehydes, ketones, alcohols, or ethers. Press pause and come back. So this is a ketone. We have a carbonyl group with carbons on carbon chains on both sides of our carbonyl group. B, this is an ether because we have our oxygen, and it is a single bond to a carbon chain on one side and a single bond to a carbon chain on another. This is an aldehyde because we have our carbonyl group that has a hydrogen on one side. D, we have an OH that's just attached to our carbon chain.